Welcome back from an ad break. So before the ad break, we looked at the questions that are practice questions based on the expansion and contraction, and also looked at the application questions again based on the very same topic. So now let's do a quick recap on what we looked at in the entire lesson. So our main idea was the expansion and contraction, and within that, we looked at the temperature and the particle model of matter. We also went on further to look at the expansion and contraction of different materials. And then we were also using certain words such as expansion, contraction, and thermal energy to better explain our main idea, which was the expansion and contraction. So we said that expansion, it is the increase in the dimension of an object or substance when subjected to an increase in temperature. So expansion goes with an increase in temperature. Whereas contraction, that's the shrinking in the dimension of an object or substance when subjected to a decrease in temperature. And then lastly, thermal energy. That's now the energy contained within a system that is responsible for its temperature. So now, what I need you to take away from the entire lesson is the following. Number one, that if the motion of the particle changes, the temperature also changes. Right? So if we increase the temperature of the particular material, then the particles making up that material are going to increase in terms of the motion. They're going to move faster and faster. And when we decrease the temperature, the particles making up that material are going to move slower and slower. So the motion of the particles will depend on the temperature change. Increased temperature, they will move faster. Decreased temperature, they will move slower. And remember, with those two, when they are moving faster, they are also going to moving further away from each other, increasing the spaces between the particles. But now when we are decreasing temperature, they're going to moving closer together and decreasing the spaces between the particles, and therefore we say in that case, the material is going to contract. If the spaces are increased, we're saying that the material is going to expand. So now, particles do not expand or compress, or that means to contract. The particles move away or approach each other, or meaning that they are moving closer to each other. So now to better explain that, we are saying when we are increasing temperature, we know that the material is going to expand. But that material, the particles making up that material are not going to be expanding. They will just be moving away from each other, which then appears that as if now the material is expanded. However, what happened is that the spaces between those particles has increased. So now, when we are looking at the particles that are contracting, we are saying that the particles, they do not contract, they do not become smaller and smaller. They just move closer and closer to each other, which appeared to as if the material has contracted or the material has become smaller. The number of particles making up the material remains the same, and therefore the particles, they do not expand. The particles do not compress or contract. They only increase the space or decrease the space between them. And then lastly, the speed of particles does not change if the temperature does not change. If I do not increase or decrease the temperature, the particles will remain. Remember that all matter is made up of particles that are always in motion. So that motion will remain like that if the temperature does not increase or decrease. So all the matter has particles that are in motion. Should I increase the temperature in that particular material or that matter, the particles that are already in motion will move faster and faster and move away from each other. But if I decrease the temperature, the particles that are already in motion will start to move slower and slower and move closer and closer together. So the particles will not change their motion if the temperature is not changed. So now, learners, I have answered a lot of questions, and now it's your turn to do so. I want to know, how can gas be measured? How can we measure gas? That's a question that I have for you. So now I hope that you have learned something about the expansion and the contraction of material, specifically and most importantly, that the particles themselves, they do not they do not contract or expand. Only the spaces between the particles is going to increase or decrease. And learners, I hope you had as much fun as I did. Until I see you next time. Bye.